For ICE candidates, we need to identify two processes, sending and receiving. Let's focus on sending first. After we created our RTC peer connection, we set the onICE candidate, which is the function that will be executed when this particular user creates or finds an ICE candidate. To do so, remember that ICE framework follows a process that consists in 3 steps: getting the device's IP address, use a stun server or a turn server. That's why when we created the object, we set the ICE servers variable. And what are these servers? These are the ones provided by Google and by Mozilla. We can use these servers for free, but it's not recommended to use it on production. In such case, you will need to set up your own set of stun and turn servers. So, every time a new ICE candidate is found, the onICE candidate event is triggered, which is similar to what happens to the onTrack event. Anytime that the RTC peer connection receives a remote stream, it will trigger the onTrack event, which is the onAddStream event. So let's create the handler for when an ICE candidate is found. So we're going to create another function, and this one is going to be called onICE candidate, the same as we wrote it above. So we're going to receive an event, and in here we're going to check if the event is actually a candidate, or if there actually is a candidate. Okay, so we're going to print it to the console, sending ICE candidate. Let's also print the candidate here. And we're going to send this to the signaling server by emitting. Now we're going to add this as a candidate event. Okay, the type is going to be also candidate. We're going to have a label, which is event candidate. This is going to be equal to SDPM line index. These are some values that are handled internally by the ICE framework. We're also going to set an ID, event candidate SDPM ID. We also need to send the actual candidate, which is going to be event candidate. But we need a comma here. And we're also going to send the room number. Okay, we're ready now. Now we need to be able to receive those candidates from the signaling server. To do so, we just need to add the handler function for the message. So we're going to add it here. Socket on candidate. This is going to receive the candidates that we get from the other peer. We're also receiving an event, and in here we're going to declare a constant candidate equal to new RTC ICE candidate, and we're going to initialize it as SDPM line and index is going to be the event label, and the candidate is going to be event.candidate. And lastly, we're going to add the ICE candidate to our RTC peer connection. Add ICE candidate. Here is the constant that we are using. Now that we have covered signaling, we can let the RTC peer connection do his job and establish the call. Let's now run the app and check if it's working. So we have the application running. Now let's go into the WebRTC training room. Gonna click on go, gonna click allow. I'm going to lower the volume because I haven't feedback in here. So now I'm going to do the same in the other room. Okay, WebRTC training and go. So I have the call established. We can see that we have the two streams here, and we also have the two streams here. And we also can see that there's a bunch of messages about the sending of the ICE candidate. We also have those same messages in the other browser. Now let's do something so we can get a more clear view. Let's add some messages in here. First of all, we're going to create or we're going to print when we received the ICE candidate. So we're going to add here in the socket on candidate event, we're going to add console log. I'm going to add the message received candidate. We're going to print the candidate. We have to replace here. Okay, now we have candidate. We're also going to make a console log when we create the offer. So we're going to add a message here. Console.log and send in offer. And we're going to print the offer in here, which is the session description. We're going to do the same when we receive the offer in here. So we're going to print console.log and received offer. I'm going to print the, I think it's session description. Oh no, it's event. So we're going to print the event. And we're going to also print the log when we send. So sending the answer. And we're going to print the session description. Okay, finally, we will add a last message in here when we receive the answer. So let's write console.log received answer. And we're going to print the event. Okay, now let's refresh in here and also refresh here. Let's get into the room again. WebRTC training. Click on go, click allow, and let's do the same in Google Chrome. WebRTC training. Now let's take a look at the messages. The first thing that we do is we send the offer. We have the SDP format in here. We can see that there is a lot of information that is sent to the other peer through the signaling server. In here, in the other peer, we see that we get the offer, and it's the same that we have sent from here. Another thing that we do in here is that we send the ICE candidates. We have 3, 4, 5. Well, we have a bunch of ICE candidates that are received in the other side. We can also see that in here, after we get the offer, we are sending the answer. And if we scroll down, we will see that we received the answer in here. And in the meantime, the peers are also sending those ICE candidates to each other, and they are receiving them. So this is all happen before the actual call. And when all this data is exchanged and correctly processed on each side, is that we are able to have our call. So that's how the call works. And now we are having our video conference, our small video conference application. The last step, I think, that we are going to add to our application is that we're going to make an example of the data channel. So when you're ready, move to the next lesson.